Right, so in this video I'm going to go through I'm starting a series of videos about electricity. It's, I guess, mostly for GCSE, but I think a lot of A-level students will really benefit from that, especially because a lot of you didn't really do electricity in your GCSEs, and so some of this wasn't really ever embedded. So I think it's really important to get these basics right. So though this is technically GCSE, it is also very important for A-level students. To start off with, the way that we describe electricity is we draw circuit diagrams, really, and I'll draw them. They look very different to actual circuits, largely because wires rarely go actually straight. They're normally curvy around, and none of the things actually look like this. But this works for explaining them. Now, the reason why I've done this impressive bit of video editing just to hide the answers is you could pause now, and you could see how many of these you can actually name. At both A-level and GCSE, you need to know all the names of these symbols. So just have a pause, see if you can name them, and then I will just quickly remove them, reveal the answers. And I'll go through what they are. So this is a switch. It doesn't matter if you draw the switch as open or closed. It really doesn't. The switch just allows you, mostly in GCSE and A-level, to turn the circuit off in between readings so things don't get too hot, which is the bane of electricity. Things heating up, the resistance is changing, and you're getting bad results. So turning it on and off is very helpful to put a switch in. This is a cell. And that is a battery. A battery is just a series of cells. Cells and batteries have positive and negative ends, and they need to line up like this. If you were to draw them facing the other way, they would kind of cancel each other out. And don't forget that though the electrons are traveling from the negative to the positive, because electrons are negative, actually current flows from positive to negative. So that's the direction that current's going to flow, and it's dictated by the battery. The long bit of the battery is the positive bit. This is a resistor. Resistors essentially just add resistance to a circuit, which reduces the flow of current because it makes it hard for the electrons to get through something, and so less of them flow. So if you put resistors in your circuit, you can have lower currents, which is useful, largely because high currents cause heating effects. This resistor will be a fixed resistor, like 1,000 ohms or something, and they might be in the circuit for various reasons. This one here is called a variable resistor. Variable resistors, the arrow represents that you can change the resistance. So you can normally change it from 0 to about it's normally 0 to about 60 ohms, I think, but they obviously change. It depends on what kind of variable resistor you have. These are very useful in circuits because if you change the resistance of this, it allows you, if something's connected in series with this and has a fixed resistance, as you increase the resistance of this, it will take a greater share of the potential difference, which means the component you're looking at will have a smaller share. So this allows you to use a fixed source of potential difference like a cell and then change the resistance, the potential difference across the different components in the circuit by changing the resistor. This is a thermistor. I think of that as an ice hockey stick, so cold, so thermistor. It's a thermal resistor, so it's just a resistor with this symbol across it, which means the resistance changes with temperature. And for this one, for these thermistors, if the temperature increases, they're called negative coefficient. So if the temperature increases, the resistance decreases. Same the other way around. If the temperature decreases, the resistance increases, which is not what you'd expect. Normally when temperature increases, resistance increases, but here charge carriers are freed in the material when the temperature increases, which reduces the resistance of it. This is, again, just a resistor, but this one's got these arrows of photons, light shining on them. So this is a light-dependent resistor, and the same thing for this one. If the light intensity increases, the resistance decreases, and the other way around. If the light intensity decreases, the resistance will increase. So you can use these in circuits like night lights or like those photo frames that come on during the day because their resistance changes and therefore the current in the circuit changes as the external condition changes. But there'll be another video on those, I'm sure. Now, a fuse is a component that prevents electrical fire because if the current flows too high, this wire melts and then breaks the circuit, so prevents fire. They're not really used anymore. Normally we use circuit breakers, electromagnets nowadays. This is a lamp. It's one of these filament lamps that you don't see very much apart from in bougie cafes because everybody has LED lights now because they're much more energy efficient. These lamps basically get so hot they glow. Ridiculously inefficient, but cheap. This is a diode. So a diode is a component that only allows current to flow through it one direction. So very useful to prevent the backflow of current. So for example, you don't want current flowing the wrong way through a cell, so you would put a diode in to prevent it from happening. And other sorts of things like that. The direction of the current is shown in the direction of this arrow. So this will allow current to flow in this direction. In this direction, though, no current will flow through it. This is a diode that emits light. So again, they have to be connected the correct way around in the circuit. Current can only flow through it in that way, but when current flows through it, it emits light. So it's a light emitting diode or an LED. Right, this is an ammeter. It measures the current. It needs to go in series in a circuit. And so it kind of like goes in with your circuit. So if you wanted to measure the current through this cell and battery combo, that's how you'd connect it. And it's called an ammeter. A voltmeter. I like to draw it like this because voltmeters go in parallel. So if I wanted to measure the potential difference across a bulb like that, I'd have to connect it in parallel, and it measures the energy, the potential energy change or the potential difference across these 2 points. And then finally, this is not on the spec, but just in case it's not obvious, this straight line, all these straight lines here, this represents just a wire, which we consider to have no resistance. Right, that's it.